Hi, my name is Gabriel. Welcome to this exam revision session on models for credit rating. Now, in fact, let me say it now. This is one of my favorite sections in this subject. As you will see when I'm explaining it, I'm quite passionate about this subject. Now, before you start off with your revision, please read these instructions carefully. So pause the recording, read this carefully, then when you're done, you can start off with your revision. Now, our revision today is based on models for credit risk. So we'll be specifically looking at the two-state model, the Merton model. People always get confused on the substitution here, the Merton model, but we're going to discuss it. And we're going to look at the Gero-Lando-Tenbo model. Now, our first question here that we're going to discuss is a lovely one. It is lovely in a sense that it's testing two sections in one question. So you will see the first question is testing the two-state model and the Merton model. So it will get you to practice two things at the same time. So let's read our question. So the question says, the company has issued a loan in a form of a zero coupon bond, which redeems in one year from now. The bond is priced at 92.78 per 100 nominal, and the recovery in the event of default is assumed to be 50%. The continuously compounded risk-free rate for 1 year is 3%. Now, the first question they ask here, they say, write down the formula for the bond price under the two-state model, defining all the terms. Now, that should present no problem at all, because you know that the price of your bond at time little t, that is redeemable at time capital letter T. Now, given that the redemption value of this bond is 1, the formula under the two-state model goes like this: e to the power minus r into a t minus little t multiplied by 1 into 1 minus delta, that multiplied by e to the power of negative the integral from little t to capital letter T of delta of x ds. Okay, so this is your formula. Obviously, you know that your r is your risk-free rate, your delta is the recovery rate, and your lambda of x is the transition intensity from not default to default. Okay, obviously this formula is derived, or it takes a similar shape to the formula we derived in the 5-step method, which we're going to discuss. Remember, in the 5-step method, we derive that the price at time little t is equal to the expected value of the payoff at big letter T given the past history, this discounted at a rate R, discounting it, you're going to multiply it by e to the power minus r into t minus little t. So this formula here is derived using this understanding here, because what is actually happening here, your 1 minus e to the power of the integral from little t to t of lambda of s is your probability of default. Now, if this is your probability of default, multiplying by delta, which is the recovery rate, you get the expected recovered amount. 1 minus that is the expected loss, and 1 minus the expected loss will be the expected gain or the expected pay off. Obviously, you have to discount this, so you multiply by e to the power minus r into capital letter T minus little t. Obviously, if you have your timeline here, your little t will be here and your capital letter T will be here. We assume that this bond is redeemable at the value of 1. So the payoff is 1. So that is the price for the that is the bond price under the two-state model. Now, the second question here say calculate the risk neutral probability that the bond will default. Well, I've just discussed it with you now. I told you that this is the formula for the probability that the bond will default. I'm given the price, I'm given the recovery rate, and I'm given that your capital letter T is 1 and your little t is 0 at time 0. So that means I can calculate this. Please note that your probability of default is not lambda, but lambda is your transition intensity from not default to default. Your 1 minus e to the power, this whole thing, is your probability of default. So I'm going to set out my equation here. If I'm setting out my equation, I know that the price of this zero coupon bond is 92.78. This is equal to redeemable at 100. So 100 e to the power 0.03, which is your risk-free rate. Then your 1 minus 0, which is 1, multiplied by 1 minus 1 minus your recovery rate, which is 50%. Now I'm telling you that this whole thing here is the probability of default. So rather than writing this tedious clumsy expression, I'm going to write x. So the only thing I'm going to do here is just to solve for x, which is your probability of default. Obviously this x here matches this value here, this expression here. So I'm going to solve for x now. So I'm sure your algebra is sharp, because now the only thing left is manipulation, equation manipulation. So I'm going to say 92.9.78 divided by 100 times e to the power minus 0.03. That will be equal to 1 minus 0.5. Just to warn you here, if you look carefully here, we have got 1 minus bracket 1 minus 50% your recovery rate. Just to warn you here, you may not say 1 minus 1 and get 0 and multiply this negative inside. You can't do that. Okay, you can't, because this here is just the same as 1 minus 2x. Really, there is no way you can simplify this. There is no way you're going to get minus x out of that. So please don't do that. Just a little warning. Even though it's tempting to say 1 minus 1, then distribute this one here, but it is actually not the case. So I'm saying 1 minus 1 minus 50%. 1 minus bracket 1 minus 50% to get this 0.5 here. Now at the matter of solving for x, because now your x, if you simplifying very carefully here, your x will be equal to 1 minus 92.78 divided by 100 times e to the power negative 0.03, all that divided by 0.5. And you're going to get your value of 0.08788 0.856. So in fact, let me round off that to 0.08789. And that is your probability of default under the two-state model. Now, please notice what I'm saying. I'm saying the probability of default under the two-state model, because we also have the probability of default under the Merton model. So you mustn't confuse the two. You'll see the examiner addresses that now. Now, the third part of our question actually deals with the Merton model, because they say assume the Merton model holds and the annual volatility of the company's total asset is 13%. So that's your sigma. So I'm trying to highlight it. So that's your sigma. So your sigma is 13%. Now, before I start this question and the next question, which is purely based on the Merton model, I want to explain something about the Merton model. Now, under the Merton model, now this is not part of the question, but I'm trying to explain something which I think is extremely important. Now, under the Merton model, let me throw in a timeline here and say this is my little t and this is my end time, capital letter T. So I'm going to say this is my initial time and this is my final time. Now, under the Merton model, if we look at the initial time here, we assume that at the initial time little t, the company has total assets made up of equities and liabilities. So I'm going to call that F of little t. So I'm going to say F of little t is the total assets of the company at time little t. This is made up of equities. So this is made up of equities plus your liabilities. Now, if you look at capital letter T, oh gosh. Now, if we look at capital letter T, which is here, sorry, something disturbed me. If we look at capital letter T, which is here, then we are interested in what the shareholders of the company and the bondholders will get. Now, under the Merton model, we know that at capital letter T, the shareholders will get the maximum of the total value of the company minus, will either get the total value of the company at capital letter T minus your redemption value of the bond or loan, or they'll get nothing. So these are the shareholders. And as for the bondholders, they'll get the minimum of F of capital letter T, which is the total value of the company at capital letter T, or they'll get L, which is the redemption value of the bond or your loan. Now, this minimum of F of capital letter T and L, believe it or not, but this is equal to L minus the maximum of L minus F of capital letter T and 0. This here is not very clear, but please take time to convince yourself that this here is true. Now, so here are your expressions. So at time T, which is your final time, your shareholders will get the maximum of F of T minus L or 0, whatever will be a maximum. And your bondholders will get the minimum of F of T and L, which is 1 minus the maximum of 1 minus F of T. Now, this is the final time here. This is the final time here. But what about the initial time little t? Any initial time little t. So little t might be 0, 1, 2, 3. What are the shareholders and the bondholders going to get? Well, that is not a big problem, because if you look here, this is the expression for the payoff of the call option. So what does that mean? That at time little t, we value we value the shareholders as a call option. So at time little t, the value of the shareholders of the company is a call option. Okay, since at the end we have the payoff of the call option. And what the bondholders will get, well, you just have to simplify this expression here. I'm going to discount the L. So at time little t, I'm going to discount the L. I'm going to have LE to the minus R into T minus little t. And if you look at this, well, this is the payoff of the put option. So I'm going to evaluate the put option at time little t. So at time little t, the shareholders will be evaluated using the formula for the call option, and the bondholders will be evaluated using this formula here. Obviously, if you've got the value of the call option, you can use the put-call parity to calculate this value of the put option here. And we know that under the Merton model, the probability of default is 1 minus phi of D2. Okay. So under the Merton model, the probability of default is 1 minus phi of D2. Okay, so that is quite important going into the exam. You must remember all these kind of things in order not to encounter problems regarding this section. Now, let's go back to the actual question. This is just an explanation of what you are really required to know. Now, if we go back to the question, the examiners start heating up this question, because now, if you go back, they say, give an expression for the risk-neutral probability that the company default, defining any other terms you use. Well, I've just stated that now. So it's a matter of defining all your terms. So the probability, the risk-neutral probability that the company will default is actually equal to 1 minus phi of D2. So which means now I have to define your D2. So your D2 is actually equal to the natural log of the total value of the company at little t divided by your redemption value. And I'm going to add the risk-free rate minus 0.5 multiplied by the volatility squared. This multiplied by final time minus initial time divided by your sigma times the square root of the final time minus initial time. So you're going to tell your examiner that f of little t is the total value, or so you're going to tell your examiner that your f of little t is the total value or total asset of the company, and you're going to tell them that your L is your redemption value of the bond or your loan, and you're going to tell them that your R is your risk-free rate and your sigma is your volatility. So that's not difficult there. Now, the next question is where things get a little bit ugly, because now they're saying calculate the ratio of the nominal loan. So the ratio of the nominal loan to the total asset value, assuming that the risk neutral default probability is the same as calculated in part 2. Now remember, in part 2 we had the risk neutral probability being equal to 0.08789. Okay, now we want the ratio of the nominal of nominal loan, the ratio of nominal loan. Now your nominal loan is the same as your redemption value, which is L in this case. So your nominal loan is the same as your redemption value, which is L in this case. So we want the ratio of L is to F of little t, which is the total value of the company. Now, how are we going to do that? So now, where do I even begin here? Now, I'm told that the question told me that, now let me quickly go back and get this one more time. They told me that the risk neutral default probability is the same as in part 2. So the probability I've just defined here, which is 1 minus phi of D2, is the same as the probability that I calculated in part 2 of the question, which is 0.08789. Okay, so your phi of D2, if you rearranging this here, is going to be 0.91211. Now you're saying, Gabriel, how is this going to help me to find the ratio L is to F of T? While wait there, obviously your F of T, because here we're starting at 0, your little t will be 0 and your big T will be 1. So this is actually L is to F of 0. That is what I'm looking for. And you remember during when you were young in high school, you were told that if I've got A is to B, this is equivalent to A over B. So my L is to F of 0 will be equivalent to L over F of 0. Okay, so let me substitute in here. So I have phi, my D2 is the natural log of F of 0 divided by L, right, plus 0.03 minus 0.05. Actually, it is so let me quickly check something here. 0.5. Okay, so this is not 0.05. 0.5 multiplied by your volatility 13%. Don't forget to square this. I have to multiply this by big T minus little t, which is 1, so I don't have to do that. And I'm going to divide that by 13%. Okay, this here, after manipulating from here, will be equal to what? Will be equal to 0.91211. Now, how are we doing then? Because now what I'm actually going to do, I'm going to work my way to find this. Obviously, if I have this, I can invert it to answer the question the examiner asked me. Now, your phi of this is actually your cumulative distribution of the standard normal. Now, what is actually happening here, I'm telling you that phi of this whole thing is equal to this here. So there exists a value little x. There exists a value little x such that the cumulative distribution of this whole thing is equal to 0.91211. Now you're going to go and check this probability in your tables. Well, unfortunately, you won't find it there, but you're going to use interpolation or in order to find the corresponding x value corresponding to this cumulative distribution probability. And the x value that you're going to find using your interpolation, which I'm not going to show here, but if you have any problems, you can contact me. That x value is 1.353875. Okay, which means this whole thing here in bracket is 1.353875 because I've got the cumulative distribution. I think that is a tricky part here. Now, what am I going to do now? I'm going to say the natural log of f of 0 over L plus 0.03 plus 0.5, 13% squared, and I'm going to divide that by 13%. That will be equal to my x value corresponding to this cumulative distribution probability, which is 1.353875. Now remember, the goal is to get this so that I can invert it and answer the question the examiner asked me. Now from here, it is, good people, it's a matter of algebra. Now I've been saying this throughout this revision, that please on the exam day, make sure that your algebra is polished so that you will be able to answer some of the questions which requires intense algebra. Because now what I'm going to do, I'm going to multiply on both sides by this so that it will cancel here and get multiplied there, and I'm going to subtract this whole thing on both sides. Now doing that, that is basic algebra, nothing is difficult there. I'm actually going to have the natural log of f of 0 divided by L being equal to 0.1544375. Now remember, the goal is to find this. Go back and read your question. Now what do I do from here? I'm going to exponentiate on both sides here. Okay, so I'm going to exponentiate on both sides so that this will cancel, and I'm going to be left with, what am I going to be left with? F of 0 divided by L being equal to your e to the power 0.15445375. Now I'm looking for the ratio of the nominal value, which is the redemption value, is to the total asset of the company at time 0. Now I just need to invert this in order to get that. So that's exactly what I'm going to do. I'm going to say L over f of 0 is equal to 1 over e to the power at 0.15445375. Now you're going to punch this in your calculator, and there you're going to get the value of 0.8568831, which is exactly what you are looking for. Okay, so a little bit demanding, requires a little bit of consideration, and you have to think. Nowhere do they talk about ratios in your notes. This is a question where you have to apply your knowledge. Now the last part of this question is even more demanding, because now they're saying calculate the ratio of the loan value. The loan value, the value in actual fact is the price of your loan or the price of your bond. So do not get confused here. If I'm saying value, if I'm saying price at time little t, that is actually the same thing. So I'm looking for the ratio of the loan value is to the total asset, and they say, okay, so I'm going to look at the second part of this question. Now let me first deal with the first part of the question. Now they're looking for the loan value, which is the price of your bond is to total asset. Now if the question is difficult, the examiner will always lead you. I don't think that's cruel to just throw you. So always look out at what you have just calculated and see if you can use it to answer the next question. So what I've just calculated is the ratio of the nominal value is to the total value of the total value of the company, or the total asset. Now, do you agree with me if I have to discount this? If I have to discount this L at a yield RY, do you agree with me that that will bring me down to the loan value or the price of the bond? So that is exactly what I'm going to do here. I'm going to multiply, so I'm going to say LE to the power minus R into T minus little t over F of 0 is equal to, now be careful, if this is my equation star, I've just multiplied my equation star by a foreign item, which is E to the power minus R into T minus little t. Now, whatever you do on one side of the equation, you have to do it on the other side of the equation. So I'm also going to multiply by E to the power minus RY into T minus little t on the other side. So I'm going to have 0.85, right? 68831 E to the minus RY into T minus little t. Now, if you look very carefully, this here will be the price of your loan, which is actually the loan value the examiner is looking for, divide by F of 0, that will be equal to this. Now you're saying, well, Gabriel, we've got a little problem here because we don't know your RY. Remember, your RY is not your risk, is not your risk free rate, but if I quickly check my note here, your RY is the yield at which your debt is calculated. Now, that is not a problem because you have got the price of the bond and the redemption value. So if you discount your redemption value at your yield, this year you're going to get the price at time 0, which is I've already forgotten the value, so my note will help me, which is 92.78. So if you solve this simple equation, which I'm sure you can find, you're going to find your RY to be what? To be 0.07493. Now you're going to take this RY and substitute it here. Obviously, your final time minus your initial time is 1 minus 0. So this is just 1 here. So this here is just 1. So doing the calculation, you're going to get the ratio of the loan value is to the total asset of the company to be 0.7950161. Okay. Now, the second part of the question, remember, we haven't done answering the question because the second part of the question says, and hence, determine the percentage of total asset represented by equity value at time 0. Now, remember, I told you earlier that at time 0 or at time little t, your total asset is made up of your equity and your liabilities. This is the redemption. This liability is the redemption value of your bond. Now, the question is looking for the percentage of equity. Let me go back again. The percentage determine the percentage of total asset represented by equity value at time 0. Now, that means I have to take my equity value, then divide by the total asset at time 0, sorry, your equity value, then divide by your total asset at time 0. Now, at this moment in time, I don't have any of those. Now, that is no problem because the examiner said hence. Hence means use what you have determined to answer this question. I've just determined that the ratio of the loan value into the total asset of the company is 0.750161. But this loan value here, I've been saying to you, is the same as the price of the bond or the loan, whatever you'll be given on the exam day. So I'm going to remove it and actually put the price, which is 92.78. So from here, you can solve for your f of 0, because now your f of 0 will actually be equal to 116.70203991. Now remember, this f of 0 will be made up of equity plus your liabilities or your debt. Now if you have got this to be this value and your debt at time 0, which is your price, to be so, now I'm going to say 116.70. Let me quickly check something in my calculator. Minus 92.78. Oh yes, I'm going to get what I want. So this L here is your debt value, is the value of your debt at time 0. So I have to be specific. Remember, this is all happening at time 0. At time 0, and this is not your redemption value, but it is the price or the value at time 0, the value of your bond at time 0, which is 92.78. So I'm going to say 116.70, this whole thing, minus this, in order to get my equity. And I'm going to get my equity to be 23.92203912. Now I'm looking for the percentage represented by equity in the total asset. So I'm going to say 23.92203912 divided by your total asset, which is 116.70203991, and there I'm actually going to get 0.204983, rounded off to 2 decimal places, to 1 decimal place, and writing it as a percentage. I'm going to have 20.5%. Okay, this video took longer than I expected. So let's look at our second question.